Hi, my name is Johannes. You might remember me from last year's Test and Press contest. This year I've got a new project to show you. It's right here on the bench. Here's a microcontroller generating two PWM signals. Those go into this analog board, where we've got a voltage reference, two analog switches, and some inductors. You guessed it, it's a PWM DAC. And I'm optimizing this for high linearity, low ripple, and fast settling time. In order to get there, I'm using two ripple mitigation techniques. The first one is adding a complementary version of the PWM signal to the output with AC coupling. That's nothing new. And the other one is using notch filters to filter out the PWM frequency and its harmonics. This way, the ripple has become smaller than what I can measure with my hobby equipment, and the linearity error is just 2 ppm of the full-scale output. Eventually, this should become a 28-bit DAC, so I'm not quite there yet. A better oscilloscope could help me identify and fix the problems that are still present in the circuit, and a 7.5-digit multimeter would help me characterize the unit, so I could compensate for the remaining problems in software. Let's have a look at the ripple measurements to see why I think that using absorption circuits as notch filters in PWM DACs could be a very effective way to bring down the ripple. I'm measuring directly at the output of the PWM stage. This is what the ripple looks like without any filtering. Adding the complementary signal brings it down quite a bit, but there would still be a lot of filtering to do. Using the notch filters instead results in a much cleaner signal. Of course, we can also combine both measures, but at least on my scope it doesn't look like that would be a good idea. This is why I joined the Test to Impress contest 2018. I hope you found my project interesting, and thank you for your consideration.